So the real thing to do is simply to comment out simplified shapes. If I do that now on this and I re-render it, and this will really, the other things you could do while that's rendering is if you knew the first 3 letters of a postal code in any region you were interested in, you could highlight it by simply changing the values in this list, or you could add to the list, as long as you also add to the data A associated with it. Okay, each value of the data here corresponds to each postal code prefix. Okay, so VOR is 1, V8R is 10, and so on. There's no meaning to the particular data, just that it's there. And I've been talking now for 37 seconds, 32 seconds there. It's finally finished rendering. Okay, by dropping the simplify shapes control, we will now have a much more detailed map of BC. I gotta move my zoom stuff out of the way and reorient this. And now I can use my bounding box, and Vancouver Island is this pickle shape over here on the south, dipping into the below the 49th parallel. If I draw a box over that little region, we should pick up Victoria. I draw a box. This is the Saanich Peninsula here. I draw a box over there. We'll get closer. There's Victoria proper. There's the region of Oak Bay. I'm going to zoom into this one here. And now we almost get the level of a street map. I need to switch to panning. And I'm looking for that circle. That's the ring road of UVic, which used to be a military base. And if I notice how clean the circle is delineated here by its neighboring region, if I zoom into there, there's the ring road. I'm just trying to orient my mind around this. Ooh, which one of these is the HSD building? Can anyone pick it out? Ah, I was in the wrong sector. There it is. There's the HSD building, which is interesting, but the people in the Victoria conference room are actually inside this building here, probably somewhere in this vertical span here. So, you know, one of the interesting things here is that this data, geographical data, is freely available and it's extremely detailed. Even the footpaths indicated that they're somehow inside the building, because they are indicated on the map, right? Okay, very good. Okay, so that's all I have there. In the solution, just below it, I gave you a bunch of other interesting looking postal code prefixes. It renders a nice colorful map. You go ahead and play with that on any size, any time you like. If you want your figure to be a different size, you can specify a fig size and give it X and a Y, the width and height rather, and it will make a slightly different sized map. And I should let you know that during the break, I noticed that there's an air conditioning control to my left. So I switched it on and it's working. It's now way better. Okay, back to the, actually, I'm gonna go back to the slides. There aren't any more meaningful slides. We looked at using libraries, so we'll recap that. Python, again, it's a batteries included language, meaning you've got a lot of standard library items. You have Python, you have the standard library. You've got methods for strings, methods for all kinds of things. Built in, free. Also free are add-on libraries. You have to install NumPy, you have to install Pandas, etc. And many, many more libraries, okay, for your data science needs. Okay, so I want to show two. Okay, yeah, these slides don't really work. Handling the large, this one here, Apple Health data, Heart PY, that's the next notebook to look at, okay. I have to just reorganize, move that down so I can click this. Go to the top. Okay, so let's look at this one. This is a different data set. And the authors of this paper I believe, are the ones that published the toolkit that we're about to use. Okay. So there's a link for the paper if you want. Again, each of these notebooks kind of stands alone. You want to deal with handling simple data. In this case, it's if there's, let me know in the chat. I haven't heard from you guys for a while. So this will serve two purposes. A, let me know that you're still here. And B, does anyone use an Apple Watch or any other kind of wrist-worn device that measures your EKG? Good, because then you can do this with your own data. You'll have to deal with getting your own data. It's actually not that difficult. I don't know how it works with Fitbits or other devices, but you can export all of your gathered health data in your fruit-flavored devices. And one of the interesting things about that is the EKG data is exported separately. You get a separate discrete files for every EKG measurement you make, which is neat. Okay. So when you do that, you'll get a data file. The data file was in your data packet that was sent to you via Teams earlier. And if you look at one particular EKG, I have anonymized this particular data. So the name Ian Fishlock is as good as made up. And so there's some demographic data there for the patient and some metadata for the actual data itself. Okay, so already the device has determined that this particular data set represents a normal sinus rhythm, no alarm bells going off. Okay, I don't know why symptom shows up. Perhaps that's a feature that simply doesn't appear in my data set. You get software version information, and most importantly, a sample rate. Now, when you're importing this data, really all the algorithm wants, all the library that we're going to use wants is the numbers that follow. So that's just the head of the file. Okay, so there's a command line here that'll work on Unix-like systems just to trim the first 14 lines off of the giant CSV file. And it is a giant. This particular CSV file contains, it doesn't say, but it contains about 16,000 readings. So the readings are very fast at 512 hertz. They last for about 30 seconds. Okay, so there's a lot of data in there, but it doesn't like the metadata in the front, so you'd have to trim it off. That's one way of doing it. Okay, so heart-py is the thing. pip3 install heart-py, heart-py, I guess, is how you do it. If you don't already have it, you're unlikely to have this unless you've gone through this. Then you simply import heart-py as HP. Imports, all these imports seem to take a lot of time the first time it's done. But there it is, 3 odd seconds, okay? I have already cleaned this data, and you have an ECG with that date and -clean on it. Okay, that's the one you need to import. Okay, so we're going to do that. Okay, that's just a string. That's the ECG data file name. That's fine. Means that you don't have to retype this code if you want to change the file name. Okay, so you do that. It's in the same directory as everything else. That's done on purpose because cross-platform directory management is difficult. So more difficult than it needs to be. So ECG data is when heart-py, when you run the get data method and pass it the file name, it's going to open the file, slurp all the data in, and return you an object. Okay, we're going to run that quick, real quick. It's just imported. Hasn't done any processing yet. Okay, we can have a quick look at it. ECG data, just the name of the variable, right? Just that. Type the name of the variable, run it. And you're not going to get all 16,000 values, thankfully. This time it's a special object called an array. Okay, and some of its values are shown to you, the first 3 and the last 3. Okay, they don't mean a whole lot. They happen to be voltages converted from some sensor measure. Okay, so before we use heart-py, we're going to just have a quick cursory look at this data. Okay, we are going to, if you don't have matplotlib, don't pip3 install matplotlib. It doesn't work. It's ipympl. Okay, pip3 install IPY NPL. Okay, we're going to load that. I don't want to debug it. Okay. I have to run plot.close just to get rid of any other plots. And just this ECG data, okay? That's the thing that HeartPY read in, right? It's just get data is just a CSV reader, okay? And the data as a CSV file has been turned into this array, this list of numbers. Okay, and there it is, okay? 16,000 odd, 15,000 odd samples at some whatever the scale is here, okay? You can see the median, the middling, it's centered more or less about 0. Okay, and that's what it looks like. There's no fancy tools. There are there on the other side. You can quickly look a little bit closer, you know, and you can see they look very smooth, right? Okay, and we can reset that, the home button this time. A lot of the various widgets behave the same way, but the UIs are all different. So it's the way it is. Okay, now if that line is a bit thick because the data is detailed, we can decrease the line width and just plot it again. Plot.close in this case now prevents that data from overlapping the data in the previous plot. Okay, and now I have a much finer line, which again, let's have a quick look at that tail end there. Okay, and there it is. There are so many data points, okay, that this thing almost looks like it's been smooth. Okay, it's not though. Let me zoom in more and more. We're zooming into like an almost useless level now. Now you can see the stair stepping, okay? This is not smooth data. This is just the sheer number of samples overlaid onto a limited number of pixels on the screen that when you go to the home view or even zoomed in, it looks smooth, but it's not. Okay, so another thing we can do this in your cursory analysis, it might help. There's a shorthand to put markers. That's what the little 0 means there, little O rather. If I plot this, we're going to get it with a bunch of markers, which to my mind has actually made it far worse. So this isn't data in this state is not appropriate for marking up in this way, but you can do it. Okay, so it's a mess. Okay, it's not appropriate to have markers or thick lines for such a vast amount of data. Unless, of course, you zoom in and then, you know, maybe you got something. You can see specifically where the data points are. But not terribly helpful. The spikes are so narrow that we almost can barely see the separation between the up stroke and the down in the sinus curve. Okay, so cursory look at it. Well, okay, we get an idea of what it is, but it's not terribly useful. So instead, we're going to switch over to HeartPY and let's see what it can do for us. Now, there's a bunch of documentation as well as the paper, and it's designed mainly to be used with PPG signals. And those signals, if you're not aware, the watch and devices like it use an optical sensor and a light to shine light onto the blood vessels and measure the pressure changes somehow, as if by magic. Okay, so those particular signals are used. So that means that this HeartPy library isn't meant for ordinary electrical EKG signals. It's meant for these ones, which serves as a good enough analog. And that's what we've got. Okay, so we know from the data header that one thing that HeartPy does not do is read any of this metadata. So it has no idea what the sample rate is, okay? The metadata tells us it's 512 Hertz. So we're simply gonna say 512. The sample frequency is 512, okay? I'm going up here to see if I've run everything. Okay, if you're not sure you've run everything, this little triangle up means run everything above, which is useful. I don't have to do it now. I can just run this because I'm confident I've done the rest. Okay, HeartPy has a graphing function called plotter, so hp.plotter. And it requires this thing called working data and another thing called measures, and then a bunch of optional things. We're going to give the chart a title. heart rate signal peak detection, that's fine. And show mean don't just generate the data for the chart, actually plot it so that I can see it. Okay, the two required arguments are working data and measures. Okay, the working data is a dictionary, a type of data container, and measures are returned by the process function. Okay, so you are not going to know this when you first start using this. So it's always good to go and look at the examples that they give you. Okay, so you call HP process, pass it your ECG data. This is the data that came from the CSV file, which we cleaned. Okay, and pass it the sample frequency, which is 512 in this case. Okay, the result of this, it spits out a what's called a tuple, which is two things packaged together. Okay, and one is assigned. The first one is assigned to working data. The second one is assigned to measures. Okay, so now we have working data and measures, and now we can call HP plotter. Okay, and pass it working data measures, and away we go. Now we can say show equals false. Maybe you don't want to see it, and there may be a very good reason for this. Okay, one reason might be that you're doing something automated and you want this to produce a result that will be used later, say by a website. Okay, so you've got this plot object. It exists now, which hasn't worked. Why hasn't it worked? Did I not run this one? I didn't. Now it'll run. Okay, so show is false hasn't done us any help, has it? Never mind. But you'll find in your directory that you should have hrtrace.png and PDF, because we told it to save those two. There they are, hrtrace.pdf. The PNG will show up right here. Okay, so it spat out this file for me. Now I can use this anywhere I like. So you could make an automated process that takes raw data in, produces visualizations, and then those visualizations get used somewhere else. Okay, and you can completely automate your workflow without having to copy and paste off your screen. So you can see what it's done. A couple things. One, it's measured the BPM. It's clever enough to have figured that out, 105.8 beats per minute. So, which is a bit high. So you might wonder what this patient is up to. And rejected peaks. It showed you that there's some bad data. There's a peak here that says it's found a peak here and it doesn't jive with the rest of them. Okay, so it signaled that for you, which is useful. Okay, and it plots all the peaks, and you know, the peaks are pretty accurate. Zoom as tight as I can into that one. It's right there on the money, as you would expect it to be. Okay. So that was a plot of some clean data. What else is in the measures dict? It's a dictionary. A dictionary is a key value arrangement of data where you've got keys and values. Measures iterable. Okay. Also, they have methods which return only the keys and methods which return only the values, both of which are also iterable. So I can say for measure in measure.keys, go and print it out, print its key out and its value very quickly. Just run it, see what happens. So there's a bunch of other stuff. This is cardiological data. I have no idea what any of this means. If anyone's a cardiologist in the audience, they may know, I don't. Some of these are useful. Standard deviations are there for your statisticals. The MAD is there, a similar measure for medians. Median absolute deviation is present there. And some other statistical things, and the calculation of breathing rate, which is useful as well. Okay, so it turns out that one of the properties of the heart, or hearts, is that the frequency with which they beat is influenced by breathing. Okay, and there's a very tight link between those two. So it's possible, if you know the rhythm of the heart, you can calculate or compute the breathing rate. Okay, apparently it's one of the reasons why deep breaths can calm your nerves. Okay, deep breaths, deep, slow breaths will slow your heart rate down. So, so the breathing rate is measured in hertz, which is great. Not terribly useful if you're having a conversation with someone oh, 0.138 hertz. Oh, well, you might want to translate that, into English. So you might say the breathing rate is 0.13. You could shorten that. There are methods to shorten the overly long overly long tails of numbers like that. On the other hand, you could just invert it, take the reciprocal instead, and compute it to breaths per minute, which is something people will have a more intuitive understanding, okay, if needs. Also, the documentation paper linked above indicates an algorithm, okay? And this is what looks remarkably like illustrations for a patent application. It may not be. But their algorithm looks for these 3 points. For every shooting up, I don't know what you call it, the technical term for that is, but when the voltage goes up, forms a peak, comes back down, when it crosses the middle, you're looking for the points at which it crosses, and then the highest value in the middle. And you're looking for those 3 things. And if you have that, that's the algorithm they use to compute the peaks, okay? May seem simple, but you're doing this on a series of numbers, so there's some figuring out to do, which as a bonus, we don't have to do because the library and its authors have taken care of that for us. One caveat though, why am I showing you this? Okay, well, fine, you can play with it. Viet has a smartwatch, so you can probably do this with your own EKG and mess around with it, just like I did. I mean, just like Ian Fishlock, all right? And that's fine. Let's say you are doing a study that involves millions of these data sets, millions of these 16,000 data point data sets, all right? Now, suddenly, you've got a library where you can run a huge loop and compute all of these numbers and look for patterns and work on any study dealing with that. Okay, so it's not about how to do it for one. It's imagine that this is now big data. Okay, and you have to write software. Well, guess what? You can write software because this hard work is done. Okay, and you can figure all of that, all the details out relatively easily because the high level stuff, the low level stuff like this is taken care of for you. I mentioned a caveat earlier, and the caveat is that if you are going to do work like this, you need to make sure that the library you're using is validated and that it works and that this data is correct. Okay, you would need to engage with a cardiologist who knows what they're doing, hopefully someone who's got some tech experience as well, and just to further validate your research. Don't rely on one particular library because somebody made it in their bedroom and published it, right? Because that's all possible. One thing that this does have going for it is that there's some evidence behind it, okay, in the form of a published AMIA paper. Okay, not to say that you should rely on that, but that's certainly one thing to look at. Okay. Anyway, that's HeartPY. We covered breathing rate. We're at the end of it. So I thought this was quite interesting. I toyed with the idea of giving you a large data set on this, but it's just too much. I think handling gigabytes of data is not appropriate for a workshop. That said, those of you that do have these devices, you do have access to gigabytes of data, especially if you've owned the devices for quite a while. Okay, the last one. This, both this data set we just looked at, HeartPY, and to some extent the ones previous and this one all have a theme in common. They're all broadly related to public health, and a key public health menace in the United States is school shootings. So, like I said, I can't show you a huge gigabyte-sized data set because it's impractical to handle it for a course like this. So we're going to mimic it, okay? And here's a data set that is an Excel spreadsheet, okay? But we're going to take the Excel spreadsheet, move it into Python, and work on it there. Okay, so it's not officially big data. Anecdotally, if your data doesn't fit in an Excel spreadsheet because it's like 1 million lines long, then it's officially big data, right? And that seems to be the dividing line between big data and regular data is the capacity of Excel, which somehow seems wrong, but I thought it was funny. So I'm passing it on. Okay, so yeah. So, well, you have access to this data. I can show it to you here. It is SSDB, the School Shootings Database. I'm going to open it directly. I've got an add-in to VS Code that opens things like that in the native application. Can you guys see the spreadsheet on my screen? On your screen?
Yep.
Thank you. Okay, so here it is. Since we have this is an Excel spreadsheet, we can do our cursory look, our sniff test, and just see what's in it. This text is too small. I'm gonna, Excel doesn't do that. Thank you very much, Microsoft. I'm gonna close the chat tool. I have to use the little buttons down here. Always with the buttons, Excel. Yeah. I'm actually not able to zoom this. Oh, it's because I'm editing Excel. There we go. Okay, so what do we have? Sources, number of news. This is an attempt at reliability, the number of times this particular event. Okay, A, what do you got? Incident ID. This is like the primary key. They all have unique incident IDs, okay, which is good. Where did we learn about this? Okay, from this list of websites. Okay, and it was reported 3 times in the news media, and so on. It's got a reliability score, which is useful for data quality. I wouldn't use this as an absolute measure, just relative to within this data set. The date that it occurred, the quarter, the school, and so on. It's a high school beside the building. You can tell whether it was during school hours or outside of school hours. What time was the first shot? The summary, this is a narrative summary. Adult male construction work fatal, shot self in leg. So they're not all, they're all terrible. No one should be shot at any school at any time. Okay, but this at least wasn't a classroom full of students, as we've had recently. And there's a narrative. So there's the potential for text mining here, which is interesting. Okay, because there's at least 3 fields that have some text in it. Okay, so and so on. Various details. Was there an accomplice, hostages, barricade? Was it gang related? Oh, go away. Notifications are irritating. Sorry, give me a second here. Do not disturb already. There, okay. Was it gang related? Was it pre-planned? So someone's come up with a list of aspects to each shooting, and data is tabulated, so it's good. Okay, so that's that. And going down rows, each one of these is a school shooting. Is it in order? I'm not thinking that it is. 2021. I'm scrolling. Okay, here's a problem with Excel right now. I'm scrolling, and I'm already lost. I have no idea where I am. I'm just trying to look for the last one. 2064 school shootings, 2022 again. So this list is not sorted, but I'm recalling that, yeah, there it is. See the number there, 1970 something. Okay, so this is quite comprehensive, going back to the 70s. I don't recall off the top of my head what the latest one is, but we can find out later. Okay, so this is bad, right? So, but what can we learn about that? It's incident, okay? That's the incident tab. Here's the shooter tab. I'm not going to bother going in detail, but it has the same primary key, okay? Here's information about the shooter, and you can cross-reference that to the incident by looking at its primary key. Again, 1970 again for that one. Okay, here's information specifically about the victim or victims, and here we're going to, here, victim, singular, we are going to have a one-to-many, or sorry, yeah, many-to-one relationship, because some shooters have many victims. Okay, so this incident ID there may be more than one of these. Here, those two are the same, right? So those two, it says 1970 51 SUT. This is the same incident ID. So both those victims link back to the same incident, okay? So really, this is like a database packaged in a spreadsheet, which is weird. But anyway, because we're about to import this into Python, it's actually useful. And there's information about the weapons, which would also be one-to-many. It could also be many-to-many, actually, but I don't know if it is. Again, analysis would reveal results like that. Okay, I'm just going to close this spreadsheet. We don't need it anymore. I don't know what I changed, but I'm not going to save it. So there they are. Okay, so we did through most of that. We've got a bunch of tabs. Now, there's a couple of ways of doing this. You could open each file and save it as a CSV. Not each file, sorry, each tab, and save that as a separate CSV. You could do that. It would be a pain, and it's probably error prone because you're doing the same repetitive action where you're not necessarily going to have exactly the right way every time. You could screw it up easily, which you don't want to do. So option one isn't great. Two, you could use a library to load the data directly from the spreadsheet. There's a whole bunch of them that does that. And that's what I did. So I went to this list of libraries that open spreadsheets in Python, and I picked the first one, which is, it looks like Open Pixel. It's not, it's OpenPyXL. Okay, pip3 install OpenPyXL. You may already have it if you've done this before. I'd never done this. So they give you this is the great documentation, and the documentation includes a working example, including a spreadsheet. And so I've duplicated some of that here. Okay, and the idea is to try this out in the workbook. And so that's the code. You can run this. So yeah, I'm remembering this a little more clearly now. This, you might notice there's three greater than signs. Okay, and it just means that somebody was running Python in a console. Okay, like this. I'm trying to make it bigger there. Took a while. Let's try that again. Yikes. Python 3. And I run that, and I can do print hello world. Just, you can use Python like a calculator, and any Python one-liners can easily be done in the console. So when you see the three greater than signs, it simply means that. Okay, so I took that and put it in here. I based this little bit on that. Okay, so the very first thing they do with you is quite interesting. They say, first of all, get the library if you haven't done it already. Really? Can I not run this? Oh, it's fine. From OpenPyXL, open import workbook. That's a utility to make workbooks. And another utility needed a bit later. I'm going to define a brand new workbook. So my workbook is workbook, and you just call it with no arguments, and it creates a workbook. I've assigned a file named emptybook.xlsx. Excuse me. Okay, choose a sheet to work on, meaning I'm going to designate my active sheet, the default sheet in there as my worksheet. I'm going to give it a title. I'm going to call it range names. Okay, I'm going to run that. Okay, if I go back to here, I'm going to find empty. Where is it? Should be there. Emptybook.xlsx. I'm going to open that with Excel. That's not right. Sorry, give me a second. We reuse this, and I think it's, I'm just going to delete it. Oh, I know what's happened. Okay, never mind. Fine, we'll come back to that. But it's good that I deleted it because it's now unambiguous. Okay, I ran that. We haven't done anything with it yet. We have not saved it. All we've done is stored a potential name for it. Step 2, we're going to add some data. For row in range. Range does what you might think. It produces a list of numbers from 1 to 1 less than this. So from 1 to 39. Okay, so I'm going to treat those as rows. So for 39 rows, append to each row 600 numbers, actually 599 numbers. Okay, so that's a lot of numbers, right? That's 40 times 600 is 24,000 numbers. That's a ton. Worksheet 2, we're going to make another worksheet. We're going to call it pi. And somewhere, F5, at cell F5, we're going to have 3.14. Great. I'm going to make another worksheet, worksheet 3. I'm going to call it data. And again, I'm going to put some more made up numbers in, okay? The actual stuff we're putting in doesn't really matter. I'm going to run this now, okay? A third of a second, okay? We now have in memory an Excel spreadsheet with a whole bunch of tabs on it. Okay, write the workbook to the file name equals dest file name. If I hover over that, it reminds me what I set it to, literal string empty book, which is fine, .xlsx. And I'm going to run that. You should be aware that Excel is natively an XML format. The X signifies that it's compressed, which is why when you try to just look at it, it doesn't look like Excel. Okay, back to my list of files. Where's again, empty book. I'm going to open that with the default application, which is Excel. And there it is. So 39, okay. E. And if we scroll, you don't need to see the numbers. You can see that they're there, right? And on and on and on and on and on. Okay, a ton of data in there. Okay, pi, recall that at some F5, I recall it was, yeah, 3.14. We dumped a value of pi in there. We didn't bother using the library. We just put the number in. And data, again, at some random, not random, but at some arbitrary point within the sheet, we put a block of data. So can anyone tell me why you might ever want to do this? What, I mean, what's going on? Why would you want to do this? Anyone have any thoughts on that? While I tidy up my space here. Chat, talk. Why would you want to have Python make a brand new spreadsheet? You think of any use case for that? Let's say you had a huge, enormous data set. And the senior executive style manager comes down to you and says, I really like your enormously large data set. I need you to process it. Yeah, that's a good one. We'll come back to that. I need you to process it every night, and so that we can make a smaller one as a summary for us senior executive management types who don't like lots of detail. Okay, and there's no way you're going to take your data set and manually muck around with it every day to produce a spreadsheet, right? You are going to automate that, and you are going to run it in an automated fashion so that every night it does it by itself and emails it to them. All right, and you're never going to hear back from the senior executive upper level echelon management because they're never going to look at it anyway, right? Such is life. It says maybe to make it faster to process later on so you don't have to load the large sheet again. Yeah, why don't you take an existing sheet, create a summary of it using Python because you want on this, that, and some other thing, and make a smaller Excel thing and send it on. Don't forget, you're the experts that know how to code, okay? And the people that make the decisions tend not to have that skill set. So you always want to be able to translate back to a common format such as this. So thank you very much for that. Right, anyway, so we did that. We made imagine this is your data and it's real data and it's important stuff. And now it exists in a spreadsheet. I'm not showing it here, but you can also automatically create bar charts and whatever charts is available to Excel and automate that as well so that a chart will appear in the spreadsheet as well as the data, right? And you can automate all of that, which is great. Incidentally, you can also automate this using Excel itself, but it uses a version of Visual Basic that is well obsolete. I would not recommend going that route at all. Something just made a funny noise in my ear. I think my earphone's about to die, so I'm going to swap. Okay. Okay, I just changed my headphone. Am I still audible? Yep, so we did that. We did this one here. We checked that the sheet was made and it has all that stuff. Okay, so back to documentation, reading an existing workbook. Yeah, so this is another exercise to do. You can go and reload that separately in another session, or at least give it, not WB, give it another name, and you should be able to reload the data completely separately and be able to manipulate it, okay? We're not gonna do that. There's no need. Instead, we're gonna load the school shooting database, which admittedly, you've seen it already. It's got multiple tabs, which have relationships with cardinality in it. So unusual for an Excel spreadsheet, but there it is. So the same thing, import load workbook this time. And we're going to load it. The file name is ssdb raw data dot extension. Okay, and we're looking for the incident sheet, which is there. That the variable name isn't wonderful. Really, this should probably say incident sheet, but whatever, it's done. I don't want to change it because I probably depend upon it. So this is about right off the bat. I'm giving you a tricky one. What's in D18 of the sheet? Okay, and we load this, and it returns none. Well, what's going on? Easiest way to find out is to go back to the spreadsheet, which we will do now. When it loads. This one does take a while to load on mine. Okay, and it was D18. There's D, there's 18. What do we got? Nothing. Not all the cells are full. Okay, not necessarily a task for data cleaning, but don't be surprised if you see none, because none is what that empty cell means, okay? Okay. Sorry, what's this? Okay, there's nothing wrong with cell D18. None is actually correct. Now change the print statement so it shows us value, any value. Okay, fine. Quickly back here, the previous one, D17. Let's have a look at that. Run that, regional, okay? So now I'm confident that, you know, we've got the targeted data that we want. All right, so let's look at one particular column. Column Q, quickly back to the spreadsheet. Q is here, it says summary. This heading is summary. Okay, again, yeah, so too much data, 16,000 lines of text. Python's not going to show it to you. This is one of the columns you could get data mining out of, and if you're doing data mining, you wouldn't simply be dumping it to the screen. However, the notebook has this feature where you can show all of this output in a text editor if you click that. Now you've got 16,000, 15,000 rather, no, wrong data set, sorry, 2,000 lines. All right, in there. Okay, useful. Okay, I just closed it. Now we're back to the original one. And because there's too much stuff there, I'm just going to clear this particular cell's output so that we can move on. Okay, so the workbook has some good usability features. We like that. Charts and graphs. Yeah, I mentioned there's another way of, you can import OpenPixel, bar chart series, and all that stuff. You can create other Excel objects within the sheet as you need. Okay, so just scanning ahead quickly. Okay, so it's time for us to load our extra tools. So we're going to do that. It's done, didn't take too long this time, which is good. So we have an incident sheet that's in WB incident. Okay, and according to the docs, we have a subtle problem here. We have to convert this to a data frame, but the problem is that the very first row of the spreadsheet has the keys to the data frame, right? It's not where you want them. Okay, let me see if I can show you. Yeah, that's a data frame. And we're going to look at the data frame. That's not what we want. This is not data. This row 0 here is not data. Those are the keys. They all need to be up here on top, right? And these incident IDs need to be tucked in as the keys, right? So there is a method to do that. I'm not going to explain it. You have to use another tools, iter tools. I'm not sure if I have iter tools. Let's find out if this loads or not. It does, good. Okay, so really all we're doing is doing that. We are moving the first row and creating a series of columns, and the rest of it becomes data. And then we're making indexes out of the keys. Okay, so we're having to basically undo what we did in Excel and turn it back into the correct format. Okay, let's look at it now. That's better, see? Yeah. Yeah, this is the info. Now we have a bunch of columns that are labeled, okay? And a count of datas and the data type. Okay, now we can do something with it. Okay, in the interest of time, we're going to do the same thing with Shooter. You can edit the code below to work with Shooter. There isn't really a whole lot to do. Shooter, really this would be Shooter data. Did I use data above? Yeah, I did. Okay, here's a trick. In VS Code, if you double click on a word, you know what, I better not change this. I was gonna say, if you double click on the word and do Command or Control D, you select all the words with the same value, and then you can edit them all at the same time. I'm gonna Command Z to get out of that. Useful tool. That one there is wrong, and so is this one, but we're gonna keep this the way it is. We don't need the data above anyway. Looks like something is messed up. Okay, hang on. I'll run all the ones above. No, okay. Okay, we're gonna skip that. Yeah, not worth analyzing it right now. It's one of those things. It was working before, but now it isn't. Those of you who are more advanced can go and have a crack at it later. Instead, we're gonna run this one. Number of news, this is a, a rough measurement. You know, if 100 news sources, you know, cite a story, then maybe there's some reliability there. Whereas if only one reports it, well, maybe it's not so reliable. Who knows? Okay. So let's plot this now. Right, now I'm catching an error here. If I didn't do this, you would get a nasty little error message, and I didn't want you guys to think that was broken, okay? So this is called a try except block. We're gonna try doing this, okay? If something goes wrong, then print out, oops, that was wrong, and then print out the actual error, okay? No numeric data columns found for plotting, okay? What are you talking about? Number news, let's go look at that. Back in Excel, there's number news. No numbers, what are you talking about? Well, it's not a number type. It seems to be flagged as general, not number, right? But you don't want to go back into the spreadsheet. This is a spreadsheet you shouldn't touch. This is the data base for the data source. We want to leave that alone. So that might be something to do with it. Let's have a closer look. So that was incident data frame, the data frame we made earlier that's correctly done. Number news, and we're going to plot it. Okay, we did that and we got a mistake. So now we're going to look at number news index 2 to see what it is. Okay, now I see a problem. Do you guys detect it as well? I will let you out of your misery this time. That's not a number. That's a string. Okay, it's number 1 in quotes. It's not a number. Okay, so instead what we have to do is do a little bit of data cleaning here. Okay, and we'll speed this up a bit. Okay, when I shrunk it, I lost my place. There it is, clean the data. Okay, Okay, it's done in here. Okay, so this is a very typical Python incident df number news. That is our column for the number of times something showed up in the news. pd.toNumeric. So basically we're going to cast every value in there to a number. Okay, and then we're going to take that newly created data frame. This outputs series rather. This outputs a new series. Okay, and then we're going to replace the original series with it. Yeah, typical. And just grab an error. Flag any errors if they happen. Okay, and we still have a problem. Null at position 15. So I'm thinking that's row 15. Number news. Well, it's probably one of these, right? These are nulls. There's a null there. That's a problem. Okay. We don't like that, so that has to be fixed. There's a null at position 15. Okay, so we're not done cleaning is what this means. Okay. Now, we can course it instead. So we can say this is the same expression, incident df, number news, except with this time, if there's an error, coerce the value. Okay. So if it's null, make it nan, something like that. Okay, we'll run this one. Okay. Right, now we've got something. Now we can take number news and try to plot it. Okay, and I'm plotting, but this time I've set figure size, I labeled the axes, I've set some ticks, I've done a bunch of things to make the chart a little prettier. Okay, and of course I did this on my desktop, so this is now far too large. 600 by 400, we'll try that. There, that fits now. Now, so this looks interesting. Kind of what I'd expected. It's starting low early on and ending high. Then I noticed, wait a minute, 2020, 2012, 1996, 1973, this is all mixed up. This data is not sorted. So we're not done yet. Okay, the other thing you can do, well, you need to, this is cleaning, and now we have to organize the data a little bit. We're moving forward. Okay, so the date column. What exactly is the date column? Is this? There, that's a date. Okay, so that's a string. It's not a Python date. Okay, but this is an ISO string, the International Standards Organization, where this string actually sorts alphabetically in the correct order. Okay, which is handy. So we don't need to turn this into a proper date object. We might want to do that later, but we don't need to do that this time because of the particular date format that it's in. Okay, so we're going to sort the entire data frame by the date column, and we're going to do it in place. So we'll end up with a replaced data frame. We do that. Okay, same thing, we're going to print it again. Again, that's too large. But so visually, it hasn't made a lot of difference, but you can see certainly that the number of times things are reported in the news does seem to grow with time, particularly in the last couple of years. So media attention is on it more than it was before. Okay. Sorry if my scrolling is making you feel seasick. Okay. We've got a few more. Here we're looking at the state column this time. We're getting the value counts this time. So this is categorical data. Using value counts gives you a very quick and dirty. Let me show you. I'm going to open up a new code block and just that. Just want to show you the value counts, right? We're going to end up with another long thing, but California had 215, Texas, this, Florida, that, right? All the way down. So that's useful for quick categorical analysis, which is plottable right off the bat. Okay, all the axes are jammed together, so it's kind of hard to see. You'd have to scroll to get some separation, right? Now, we're not doing anything advanced here. So, because the thing is that California may well have more shootings than Texas. California also has more shootings than Rhode Island, for example, but Rhode Island's population is tiny. So we're not seeing anything per capita here. Okay. Certainly, there are a lot of shootings. Okay. I guess because it's 3 minutes to, we're going to leave it there. There's more stuff here for you to look at. We mentioned that each tab in the spreadsheet has keys. Well, it's possible to join one data frame to another using those keys. Okay, in the remainder of the worksheet, it gets a little advanced. So this was really if we had extra time to do it. Okay. All right. So that was the school shootings database. And going back to the slides, really just wrapping up. The goal today wasn't to turn you into visualization experts. It wasn't to turn you into Python experts. It was to show you that you can do visualizations with Python and that you can handle data sets that are fairly large with ease, with little programming skill. The more you do this, the more adept you'll get and the more useful you'll find Python. You can use it day to day. Okay. If you work with data, you work programmatically these days. Use a Python notebook. It's great. The other thing, hopefully you saw, is that by combining code and notes, the notebook itself becomes a very useful tool for you to pursue your careers. There are many other kinds of notebooks. All right, so with that, I guess we're going to hand it back to Lois for goodbye. Thank you very much for being here. I'm going to stop sharing my screen and wish you the best.